All right, let's say that the mean that teachers make in America is $50,000 and that the standard deviation is 10,000. And this is skewed to the right because there are a few people who make a lot and many people who make less. So we're going to choose 50 teachers and find the probability that you would get a mean that's bigger than 55,000. So the expected value of x bar is equal to 50,000. The standard deviation of x bar is equal to 10,000 over the square root of 50. Now, because it's skewed to the right, we wouldn't use a normal, but because of the central limit theorem, which is what we're learning in this section, and n is bigger than 30, we can say that this is going to be approximately normal. So, here's my normal curve. The mean of x bar equals 50,000. And the standard deviation is equal to what this number would be, which is 1414.2. So 55,000 is going to be way out here, and it's not going to be a whole lot. So let's find out what the z-score will be. 55,000 minus 50,000 divided by 1414.2 turns out to be 3.54. The probability that z is bigger than 3.54 using your normal CDF is 2.035 times 10 to the negative fourth. So there's almost no chance that we would get an average above 55,000 if we surveyed 50 teachers. Alright, so let's say we have another situation where the mean of the whole population is 20, the standard deviation is 5, and we're going to survey 35. We're going to do a random sample of 35, and they don't tell us what the distribution looks like. So once again, we're going to use the CLT because 35 is bigger than 30. And so we can say that our distribution for x bar is going to be approximately normal, where the mean of x bar is 20, the standard deviation is 5 over the square root of 35, which is 0.845. So the mean of x bar is 20, the standard deviation is 0.845, and we're going in between 18 and 21. Sorry, I drew 18 way too close. 18 should be farther down here. And we're going to get the area in between them. So the z-score for 18 is going to be 18 minus 20 divided by 0.845. And the z-score for 21 is going to be 21 minus 20 divided by 0.845. And so I got the answer of negative 2.37 over here and 1.18 over here. So we want the probability that z is in between these two numbers. And I'm going to use my normal CDF again to get 0.872. So that's the probability that we get in between 18 and 21 in this particular problem. And so those are two more examples of the central limit theorem finding means and their proportions.